Hello guys, I hope you're doing good. In today's video we're gonna have a closer look at the oscilloscope, or in this particular case at the oscilloscope of the UniTrain. But don't worry here, so the information you will get here you can use with any other oscilloscope basically too. So we're just focusing now our product, but like I said, there are informations which have a general meaning. So that's the UniTrain interface, what you see here, and yeah, we're paying not too much attention right now to digital in, digital out and all the other things. What we are focusing today is channel A, B, C and D, because that are more or less the input channels for the oscilloscope. Everything what you connect here can be measured in the LabSoft software with the oscilloscope tool, and there you see what the measurement results will be. The little bit tricky thing is here, some of you who have dealt already with oscilloscope, they were lucky when they find out about the auto tune button basically. So this button puts yourself in the lucky position that the oscilloscope will find or try to find the right adjustments for your measured signal on its own, so that you don't have to do anything. But of course the UniTrain does not have this function, as we want to make sure when it's used as a training system that the people understand what they're doing there and why they do the adjustments in order to measure the right signal. So now let's have a look at the oscilloscope in the LabSoft course. So it doesn't matter which course we are using for that, basically we'll find it in any course. So we go to Instruments, Measuring Device, Oscilloscope. Then it's asking for us, for example, to connect to the device. You have three different possibilities: USB, wireless, Wi-Fi and simulation. As I don't have connected right now, we just use the simulation mode. So let's make it a little bit bigger here. So this is now the measurement area, basically what you see here. On the right side you have the different adjustments, and right now we are in the 2-channel mode. You see it here, A and B. You remember the picture of the UniTrain where you also have the A and B channel, so that would be everything what you connect to A and B would be measured on these 2 channels here. But of course we can make it a little bit more complex, so we click here, down here on that button, then we switch from the 2-channel mode to the 4-channel mode. And now same story again, but with C and D as well. So let's have a look at the different adjustments which you can do here on the right hand side. First is the time division. So that means the time which passed by for each division. So division is this one here, from that to that, 1 division, 2 divisions, 3 divisions, 4 divisions, 5 divisions and so on. In that with this adjustment it means that from here to here this shows a time of 100 nanoseconds, and we can change this now from 100 nanoseconds to 1 microsecond, millisecond, up to 10 seconds. So this depends on what you want to measure. If you have very fast signals, you of course need a very short time. If you want to measure a slow signal or a signal where it's important to measure it over a longer time, you can choose one of these here. So for example, if you want to show the start of a high voltage system, it makes sense to choose one of those here. If you measure the CAN bus, you are more in that area here. So, and this of course counts for any channel, so you can't choose different time divisions for different channels. The time division counts for any channel. Then we come here to the different channels. So while we have here focused on the X-axis, we are now focusing this axle here. Okay, so this is now for the amplitude basically. On tells us that the channel is on. When we click on it, it's deactivated, so we won't see it here. Volt per division. So this is now the same what counts for the time. Here now you can switch or choose between different divisions which show different voltages. So from 20 millivolt up to 10 volt. When we choose, for example, 10 volt, that means from here to here we have 10 volt. So when a signal now goes up to here, we know that we would have 30 volts. At this amplitude over the certain time. Invert, pretty easy. That means it just is inverting or mirroring the signal So for example, if you have a rectangle signal which goes up here, it will be inverted and be down here then. Then we have the different modes, AC, DC, and ground. So that's more or less important what you measure. If you measure a DC signal, you can stay with DC. If you measure AC signal, you should go here. And the Y position here just moves the graph up or down. But just make sure not to confuse yourself. When you go here, for example, you are still at 0 volt, okay? It's not now minus 10 volts. So you have to make sure if you move or if you shift these channels that you do not mix that up. Therefore, it's a little bit careful to do it. Basically, just do it when you really want to see the difference in the signal. This is absolutely the same for the other channels here. And then we come to the trigger. So the trigger, you can choose one of the channels, and it means that it will catch the signal basically, or trigger on that signal. For example, when you have an let's say it can be a high voltage signal, it can be CAN bus signal, but it also can be an signal from the engine management. For example, for the motor position sensor, for the inductive sensor, you can choose it. Then you have the rising edge or falling edge. So that means here it will trigger on the rising edge. When you go here, it will trigger on the falling edge. So when the signal don't have a falling edge on the oscilloscope, for example, because it raises up to a certain value and will stay there, it can't be triggered then. So you have to make sure that you really look if you want to go for the rising or for the falling edge. Single means that you just do one snap of it. So basically, when you do single and it triggers then on the signal, it will automatically change to stop. And then stop, it means it stopped the signal. Okay? So also here with this one, when we, for example, go to channel A, you see now we have a little cross there. And level here goes in that direction or moves the cross in that direction, and pre moves it in that direction. So when we have a look here, you see I can now move the cross to the position where I want to trigger or stop the signal. I also can say when now the trigger is active, you see it here with this red lamp, and when I have the right signal, but I just want to stop the picture so that it doesn't move anymore and that it stays there, I can click on my own on stop, and then it will freeze the screen basically, or the oscilloscope screen. Down here there is another special channel. We can activate that. Here you see it when the new color comes into the game. That's a calculation channel, and this is where we can add or multiply. Here again we have a different kind of voltage per division which we can choose, and this calculation, depending on if we are on the 2-channel or 4-channel mode, so it will add or multiply the 2 other channels. So the calculation channel will be an addition of A and B, or for example a multiplication of A and B, even when you go to the 4-channel mode, then with the 4 channels basically. Down here we have the cursor, and this is for channel A and B. When we go back to 4-channel mode, then we have the 4 channels, and this is where we can choose the cursor. And now you see it here. We have, here's our trigger, which we also can move now by the mouse click. So when I leave that, you see that's gone. And here we have our cursor. So with this cursor I can measure basically everything when there would be a signal now. Here is the other part of it. So here I really can see between two areas, what can I measure inside this areas. And you see it here, it's the delta then basically of this, delta of time and delta of that, what you measure here. So when I go down, you see it switched then to 10 volts. Okay, that's basically exactly what we said before. You can choose between this screen and the standard screen by clicking here. So When you click here, you see it's standard. When you click again, now you have this more complex view where you see the different trigger when you have activated it, or the trigger when you have activated, again here, or calculation can go, or the cursor. So like I said, cursor here, and of course, sorry that I forgot before, cursor here in order to measure the time. So that means here with these two you can measure the delta of the time, and with these two you can measure the delta of the amplitude. So now we have a look at the oscilloscope with a real signal. I've just using the function generator of the UniTrain and put out a sinus voltage with 100% amplitude and a frequency with 1 kilohertz. And now you see it directly. I have put it on both channels, so the same signal on channel A and B. You see it when I put this down and activate this one. There you see we have, when we change the Y position, you have exactly the same signal just on A and B. So but now we get rid of B, that you just see the A channel. And now the first trick, if you want to get it back on the 0 line and you just want to adjust the line, you can go to ground, and this shows you the 0 level basically. So when you go up here, now I know that I'm back at a 0 line, and I can go back then to AC. So what does AC and DC do? You won't see a difference here, but DC shows the whole signal, so all the AC parts and the DC parts. When you click on AC, there's only showing the AC parts of the signal, but you see it's not a difference here because we just have an AC part here, so there's no DC which can be removed on the EC adjustment. When we now change the time division, you just see what happens. So now we're on a really fast one, and you just you can recognize the signal anymore because it's at 1 kilohertz. When we go now to 500 microseconds, you see it becomes easier to see the sinus. 1 millisecond is perfect here, and when you go higher, you get then a weird sinus signal basically, but this is just because of the time, the long time division here. So we go back to 1 milliseconds. When we go now to channel A and we're working here, you see now how we can change the division of the voltage. So basically it's now at 10 volt. When we go to 5 volt, basically what you see that the amplitude is shown bigger, as one division is now not 10 volt but 2 volt. But if you change this, of course you don't change anything in the amplitude. If I want to change the amplitude, I have to go to the function generator and really change the amplitude, what you see here. Okay, so this is not changing the amplitude itself, it's just changing solution, how you what's the solution of the signal or of your amplitude basically. When I would put it to invert, you won't see a difference here, but basically this signal will be mirrored. Let's come now to the trigger. When we come to channel A, you see now this black cross over here. When we switch to that view, it will change and you will have T. This is what you see here. T. We remove the cursor for now. So this is just the trigger now where you can now change the X and the Y position. So basically what we do now, we can now say we go here and we go here. So now the trigger will be set to here as we are on a rising edge. When we go to fallen edge, you will see it jumps over here to the fallen edge, pretty easy. Normally we can also adjust the position of the trigger with these buttons here, but we don't have to when we use this view, as we then can directly use the adjustments over here. When we now go to single, it will directly go to stop because it catch the signal and then stop the signal. So let's go back. I can directly go to stop now, and when I do stop, I can even now deactivate the signal. You see it here. The signal is still present as this picture is frozen. Let's jump over the calculation channel. So basically the calculation channel will be a new channel, and this works now on add or multiply. So this tries to multiply or add channel A and channel B, and yeah, we have on both channels the same signal, so you get the result what you see here in the oscilloscope, basically, where you can also do the fancy stuff with moving the Y position and invert the signal. So, but let's go away from here. Now we have also channel A and channel B for the cursor. So let's go to channel A now, and now you see again, I will remove the trigger, and now you see we have now the cursor where we, for example, can check the amplitude, which you then see something like here, 10 volts. You see it fits here. Or you also can go for the frequency, 1 kilohertz. You see it here, of course, from one division to one division, it's 1 kilohertz, and so you can move this through the whole signal basically, and just see what you find out there. You see it one as frequency or as time. At last, we just have these buttons over here. So basically here you can change the how the different signals are viewed to each other. So when X to T, the signal is like the signal refers to the timeline. When you go here, this is now where you don't do it against the time, but two signals against each other. This is why it looks like a little bit weird here, so it doesn't make sense. Normally you do all the measurements in the value against the time. Otherwise, when you have to use this, there will be an info that you have to switch to that mode, okay? And very important for the oscilloscope here at the UniTrain, when you press the button F1, you get directly into the help. So, of course, this counts for the UniTrain oscilloscope, but I hope this helped a bit, as all the adjustments here can really be transferred to any other oscilloscope. So, trigger, calculation channel, more or less, cursor, and the different channels and the adjustments, that's pretty typical for all the other oscilloscope. So like I said, if you have more questions or do you want to have more info on such general things, just let us know. Otherwise, I hope you had a great day. It's soon Christmas, so I wish you a Merry Christmas, a great time. I hope you have a few days off and a Happy New Year. Have a good one, friends. Bye.